Question 1A. Work out the value of this calculation and write down all the figures on your calculator display. So I'm going to enter this into my calculator exactly as it looks there. So I'm going to start with the fraction button because everything's in a fraction, and then on the numerator, and then the denominator, it's 6 plus 2.1, and it's 2.1 that's squared. Enter that in my calculator. It says write down all the figures. So I'm going to write down everything that I can see there. Work out the value of the reciprocal of 0.625. So the reciprocal, it's easy to get it in fraction form. So I'm going to write this as 625 over 1000. For the reciprocal, we're going to flip it upside down. It's whatever we would multiply this by to get 1. So the reciprocal is 1000 over 625. But I'm going to want to try and simplify this. So let's put this in our calculator because it's a calculator paper. And that simplifies to 8 over 5. And that's what I'm going to pop on my answer line. Question 2. Write 60 as a product of its prime factors. So I'm going to do a prime factor tree. Two numbers that times together to give me 60. Well, I'm going to go with 2 and 30. Remember, you can use your calculator if you need to. That's not a problem. 2 is prime, so I'm going to circle it, and that ends that branch. Two numbers that multiply to give me 30. 2 and 15. 2 is prime, so I'll circle it to end that branch. Two numbers that multiply to give me 15, 3 times 5, both of which are prime, so now all my branches have ended. So to write it as a product, product means multiply, so it's 2 times 2 times 3 times 5. I can write that on my answer line, or I can combine any matching numbers as a product with powers in index form. Doesn't state which form it wants my answer in, so any of these are going to get me those marks. Question 3. There are 48 counters in a bag. There are only red counters and blue counters in the bag. The number of red counters to the number of blue counters is equal to 1 to 2. Helen has to work out how many red counters are in the bag. She says there are 24 red counters in the bag because 1 is half of 2 and 24 is half of 48. Is Helen correct? You must give a reason for your answer. Well, I'm going to start by working with this ratio to see if she is correct, because I know there's 48 counters in total and they're split red to blue. Well, that 1 plus 2 tells us there's 3 parts in total. 48 divided by 3 is 16. So I would do 16 times 1 and then 16 times 2. These add to 48, 16 plus 32. So actually there's 16 red counters, whereas Helen has said there's 24. So no, Helen's not correct. There are 16 red counters. Question 4, we have this double inequality where n is an integer. An integer is a whole number. Part A, write down the greatest possible value of n. So n can be any value from -2 through to 5. It could be -2 because of that equals sign, but it can't be +5 because there's no line underneath. It's not an equal to symbol. So the greatest possible value of n, if it's an integer, must be 4 because that's the whole number that comes before 5. On the number line below, show the inequality -4 is less than or equal to m and m is less than 1. So we want a circle at -4 and a circle at +1. We're going to join both of those circles with a line. It's our range of values. And then we're going to look to see if we need to complete any of these circles, if we need to fill them in. So this is less than or equal to, so that's a filled in circle. This is less than, so that's not a filled in circle. So if it's an equal to symbol, we fill it in. If it's not, we don't. Part C, solve this inequality. So I'm going to solve it like I do a linear equation. So the first thing I want to do is add 4 to both sides. So that leaves me with 2/5 g is less than 6 plus 4, which is 10. Now I'm going to divide by 2/5, and I'm just going to do this in the calculator because I've got a calculator, so why not? So I'm doing 10 divided by 2/5. So that gives me an answer of 25. So this whole thing, including that inequality symbol, needs to go on the answer line. Question 5. Here is a triangle and a rectangle. All measurements are in centimetres. The area of the triangle is 10 centimetres squared greater than the area of the rectangle. Work out the value of x. So the first thing I'm going to do is I'm going to form some expressions for the area of each of these two shapes. So to find the area of a triangle, it's base times height, and then we divide by 2. So the base is 8, the height is 6x, and then we would divide by 2. So 8 times 6, so that's 48x over 2. 48 divided by 2 leaves us with 24x for the area of the triangle. So let's do the rectangle. So we would do length times width. So we would do 5 times 4x subtract 1. These brackets are important because it's 5 times everything in this expression here. So if I expand those brackets, 5 times 4x is 20x, and then 5 times -1 is -5. So we've got an expression for the area of both of those shapes. Now it tells us that the area of the triangle is 10 centimetres greater than the area of the rectangle. So this 24x must be the area of the rectangle, subtract that 10 centimetres extra because it's 10 centimetres extra because it's 10 centimetres greater. This is 10 centimetres bigger, so we've got to add 10 centimetres to the area of our rectangle. Now, let's simplify the right-hand side. So we have 20x, -5 add 10 is +5. So we're going to solve for x because it wants us to work out the value of x. So we're going to subtract 20x from both sides. And then we're going to divide by 4. So x equals 5 divided by 4. You can write it like that on your answer lines, 5 over 4, or if you want to give it as a decimal, pop it into your calculator and then get it in decimal format, which is 1.25. So we're going to put 1.25 on the answer line there. Question 6. Last year, a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. The weight of the paper recycled to the weight of the glass recycled is written in the ratio 12:7. Calculate the weight of glass that the family recycled. So this ratio deals with paper and glass. Paper and glass is only 57% of this amount. So let's start by finding 57% of 800. So 57% as a multiplier is 0.57. If you weren't sure about that, do 57 divided by 100. Pop it into decimal format, 0.57. So if I do 800 times 0.57, that will tell me 57%. So 456 is 57%. So that is paper and glass. So 456 kilograms, paper and glass. Now we're only interested in the weight of glass, so now we need to use this ratio here. So it's paper to glass. So paper to glass is 12:7. 12 plus 7 is 19. So there's 19 parts in total. So I need to share the 456 kilograms into 19 parts. So 456 divided by 19 is 24. Now I'm only interested in the weight of glass, so I could just multiply this side by 24. So 7 times 24 is 168. So 168 kilograms of glass. You could double check, because if you do 12 times 24, which is 288, when we add these together, we should get 456, which is what we were sharing. But the actual answer for the answer line is simply the part for glass, which is 168 kilograms. Question 7. A number D is rounded to 1 decimal place. The result is 12.7. Complete the error interval for D. So this is the error interval. So we're looking for a lower bound and an upper bound. If we've rounded to 1 decimal place, 1 decimal place is in the tenths column. So 1 decimal place is to the nearest 0.1. Half of 0.1 is 0.05. So for the lower bound, we do 12.7 subtract 0.05. Which is 12.65, and then for the upper bound, we do 12.7, add 0.05, which is 12.75. Question 8. Tamsin buys a house with a value of 150,000. The value of Tamsin's house increases by 4% each year. Rachel buys a house with a value of £160,000 and the value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house has the greater value? You must show how you get your answer. So if we're increasing by the same amount each year, we're going to do compound interest for 2 years. So let's start with Tamsin. So Tamsin started with a house value of £150,000, but it increases by 4% each year. 4% is 0.04 as a multiplier, but if we've increased by 4%, we're wanting 104%, wanting the original plus that 4%. So our multiplier is going to be 1.04 and to the power of 2 for 2 years. So let's pop that in our calculator. So that's £162,240 at the end of 2 years for Tamsin. Let's do the same for Rachel. So Rachel's was £160,000, increasing by 1.5%. So 1.5% is 0.015. So 101.5%, because it's that increase, is equal to 1.015. So 1.015 still to the power of 2 years. Is 164,836. Whose house has the greater value? Well, Rachel's has the greater value, so you can write Rachel's nice and clearly for them to see. Question 9. The cumulative frequency table gives information about the ages of 80 people working for a company. So this is our cumulative frequency table, and we'd expect 80 to be the last value because they've been added up as they go. On the grid opposite, draw a cumulative frequency graph for this information. So here's the grid that we need to use to draw this cumulative frequency graph. This is the table we're going to use. So with the cumulative frequency graph, you need to use the end point plotted against the cumulative frequency. So for this first one, we're going to go across to 30, up to 20, across to 40, up to wherever 48 is. Be careful with your scale so you know how much it's going up in. I know that each of these smaller squares is worth 1 because there are 10 between these two values here. And then we're going to 50 and up to 64, 60 and up to 75, and then 70 and up to 80. I'd recommend that you do this in pencil just in case you make a mistake, but now we need to simply draw a smooth curve through those points. It doesn't have to go from 0, but you can join it to 0 if you want to. Just needs to be a rough, smooth curve. So that's part A. Part B, use your graph to find an estimate for the median age. So the median, remember, is the middle. So we want the middle age. So we've got 80 people in total. 80 divided by 2 is 40. So the middle age should be when we have a cumulative frequency of 40. So we're going to take 40 in our cumulative frequency, read across to our graph, and then read down. And then we're going to estimate this value here. From 30 to 40 is 10. So I think that's 36. So an estimate for the median age would be 36. Question 10. A biased dice is thrown 60 times. The table shows information about the number that the dice lands on each time. So we've got the number on the dice and the number of times that it lands on this number. Gethin throws the dice twice. Part A, work out an estimate for the probability that the dice will land on 6 both times. So the first thing we need to do is find the relative frequency that the dice is going to land on a 6. So if it's thrown 60 times, 15 of those times it landed on a 6. So it would be 15 out of 60 for the relative frequency. And if we want it to land on a 6 both times, then we would multiply that frequency together. So 15 over 60 multiplied by 15 over 60 is equal to 1 over 16. So we're going to stick that on our answer line. Sally is going to throw the same dice n times and record the number it lands on each time. She will use her results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? So if we want a more reliable estimate, then the value of n, so the number of times that they throw the dice, needs to be more than 60, because the more times we carry out an experiment, the more accurate our results are. So n must be greater than 60. Question 11. Use algebra to solve the simultaneous equations that we have there. So I'm going to make the y terms the same so I can eliminate y. So I'm going to multiply this equation by 4 and I'm going to multiply this one by 6. So I've multiplied each equation by the coefficient of the y in the other equation. So 2x times 4 is 8x, 6y times 4 is 24y, and 5 times 4 is 20. Remember, at any point you can use your calculator here. 3x times 6 is 18x. 4y times 6 is 24y, but it's a negative. And then negative 12 times 6 is negative 72. Again, you can use your calculator at any point there, guys, because it's a calculator paper. Especially if you're dealing with that negative calculation, just to make sure you get the correct sign in your answer. Now that the y terms have the same coefficient, I'm going to look at the sign in front. The sign in front is different, so to eliminate the y, I need to add these two equations together. So 18x add 8x is 26x. The 24y, subtract the 24y because it's 24y plus negative 24y. It's going to cancel that out. And then 20 plus negative 72 is negative 52. Now I'm going to divide both sides by 26. So negative 52 divided by 26 is negative 2. So I'm going to pop my x value there on the answer line. Now I know my x value, I'm going to substitute it back into one of these equations to find y. So I'm just going to use this first equation. So 2x add 6y equals 5. If x is negative 2, that's 2 times negative 2. 2 times negative 2 is negative 4. So now it's a case of solving for y. So I'm going to add 4 to both sides. Then I'm going to divide by 6. Now if I put 9 over 6 in my calculator, I can convert it into decimal form. You could write 9 over 6 on your answer line though. It's equivalent, but it's also equal to 1.5. So I'm going to put 1.5 on my answer line. Question 12. The points A, B, C and D lie on a circle with centre O. A, B, C, D is a rectangle. So we have this circle with centre O and then we have a rectangle here, A, B, C, D. AB is 8 centimetres. They've already put that on the diagram for us. BC is 10 centimetres. Work out the circumference of the circle. Give your answer correct to 3 significant figures. So circumference is pi times diameter. We don't know the diameter of the circle, we need to work it out. The diameter of the circle goes from one edge of the circle to the, so one area of the circumference, well, start again, one side to the other, and it goes through the centre. So if I draw that diameter on here, we can see that it's actually the diagonal of the rectangle. So if we use the information for the rectangle to find the length of the diagonal, we can then find the circumference because that is also the diameter. So what we'll notice is a rectangle has right angles. So here, regardless of which triangle we choose to use, we will have a right angle triangle. So let's go with this one. So I know that this length is 10 centimetres. I know that DC must be 8 centimetres because it's a rectangle and that's the properties of a rectangle. So now I can use Pythagoras to find this length here, DB. So the length DB squared, or the diameter squared, is equal to 10 squared plus 8 squared. So 10 squared plus 8 squared is equal to 164. But I only want the diameter itself, so I'm going to square root that. So the diameter is 12.8. I'm going to leave it there for that one. So this is the diameter. Now we can work out the circumference. So the circumference equals pi times the diameter. I've actually left it in my calculator. So even though I've rounded it here, it's staying quite accurate here. So I'm multiplying by pi. So the circumference is 40.23201613. Now it wants our answer to 3 significant figures. 1, 2, 3. That 3 doesn't change the 2. So the circumference to 3 significant figures is 40.2 centimetres. Question 13. ABC is a triangle. So ABC is a triangle. Calculate the size of angle BAC. So BAC. So this is the angle that we're aiming for. Give your answer correct to 1 decimal place. So this isn't a right angle triangle. So what we would do here is we would either use the cosine rule or the sine rule, depending on the information that we have. So we're trying to find this angle here that's enclosed by these two sides. We would use the cosine rule if we knew that side length there. We don't know that side length there, so we're not going to use the cosine rule, we're going to use the sine rule. And I'm only going to use 2 parts of the sine rule, so A over sine A equals B over sine B initially. Now what this means is I use the angle in the opposite side. Well, that means I'm going to have to start with this angle here, because I've got the opposite side here, and then I've got an angle on an opposite side. So I'm going to have to use this information to find the angle at C, and then I can use the fact that this is a triangle to find the angle at A. So let's substitute in what we know. We're trying to find this angle. So the first thing I'm going to do is I'm going to flip the sine rule upside down because I'm finding an angle. So we're going to do sine of the angle at C, which is Y, over 15 equals sine of the angle at B, which is 70 over 18. So to find sin C, I would multiply by 15. And then to find C, I would do the inverse sin of everything on this side. Okay? That would give me the angle C. Now what I'm actually not going to do is work that out. You can if you want to. Stick it in your calculator and work it out. But I know I'm going to take that angle and this angle away from 180. So to find angle BAC, I'm going to do 180, subtract that 70, subtract this here. So subtract sin to the -1 of 15 times sin 70 over 18. It just saves me some time doing it this way, because if I'm confident with my calculator skills, I can type it all in. So we have 180, subtract 70, subtract sin to the -1 of 15 times by sin 70 over 18, and then let's close that bracket. So that tells us that angle BAC is 58.45681.063. We want 1 decimal place. That 5 is going to round the 4 up, so it's 58.5 degrees. Question 14. Show that the algebraic fraction can be written in the form here where a, b, c and d are integers. So a, b, c and d are whole numbers. So we've got a quadratic equation on the top and the bottom of this fraction. So we're going to factorise both of those quadratics and then we can simplify. So if I factorise the numerator, I want two numbers that multiply to give me -6, add together to give me -1. So that could be 1 and 6, 2 and 3. Well, 2 and 3 have a difference of 1, so let's pop them in. I want a -6 and a -1, so it'd be +2, -3, because +2 times -3 is -6, and then +2 subtract 3 is -1. So now I need to factorise the denominator. Now one of these equations is going to match, one of these brackets, sorry, is going to match, so that's a helpful thing for me. So two numbers that multiply to give me -3, add to give me -5, but one of them is going to get multiplied by 2. So we're definitely going to have a 2x and an x. So -3, my only options are 1 and 3. So let's think about this carefully. I'm aiming for -5 and one of these numbers here is going to get multiplied by 2. So I'm going to put 3 there and 1 here because 2 times 3 is 6. And then the 1 and 6 have a difference of 5. I want -5, so it's going to have to be +1, -3. 2 times -3 is -6, add 1 is -5. 1 times -3 is -3. And then I have a bracket that matches. So this is this algebraic fraction fully factorised. Now I can cancel out that common factor on top and bottom to leave me with x add 2 or divided by 2x add 1. A is 1, B is 2, C is 2, D is 1. They're all integers. They're all whole numbers. Question 15. Here are the first 4 terms of a quadratic sequence. So that's important. We've got 3, 9, 17 and 27. Find an expression in terms of n for the nth term of this sequence. So let's find that first difference. So from 3 to 9 we add 6. 9 to 17 we add 8. 17 to 27 we add 10. Now we need to find the second difference. That's the difference between the differences. So from 6 to 8 we add 2. From 8 to 10 we add 2. So we're going to half that second difference, and that tells us we have 1n squared. So I'm going to generate that n squared sequence now. So we've got 4 terms, 1, 2, 3, 4. So first term, second term, third term, fourth term. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And now we're going to see, we're going to compare this sequence with the sequence that we're aiming for. So if I write this down here, we've got 3, 9, 17, 27. So to get from n squared to our sequence from 1 to 3, we add 2. 4 to 9, we add 5. 9 to 17, we add 8. 16 to 27, we add maths 11. So now let's find what we're doing, what the rule is for this difference between our n squared and the sequence. So 2 to 5 we add 3, 5 to 8 we add 3, 8 to 11 we add 3. So we're going to have 3n added, and then to get from 3 to 2 we take away 1. So our nth term is n squared plus 3n take away 1. Question 16. The histogram gives information about the number of hours some students used their phone last week. The histogram is incomplete. So we have frequency density, number of hours the phone was used for. It tells us 28 students used their phones for between 30 and 40 hours. So for between 30 and 40 hours, this bar represents 28 students. So 28 between 30 and 40. Then it tells us that 24 students used their phones between 40 and 60. So for the last section here of the histogram, Use this information to complete the histogram. So to be able to represent these 24 students as a bar here, we need to know what the frequency density scale is. Now I know that this bar is worth 28 students, so what we would have done is the area of this bar represents those 28 students. So if I did 28 divided by this class width here, so 28 divided by 10 tells me that that's height of that bar must be 2.8, because 2.8 times 10 gives me that 28 people. So if I follow across here, this is 2.8. So if that's 2.8, let's see if we can figure out what this scale goes up in. So we've got 10, 20, 28 small squares there. So there's 28 small squares. Each small square must be 0.1. So that means that is 1, that is 2, 3, and that would be 4. So 24 students use their phones for between 40 and 60 hours. The class width between 40 and 60 is 20. So 24 divided by 20 gives me a frequency density of 1.2. So this bar is going to go up to 1.2, and it's going to spread across the whole class width from 40 to 60. So that's part A. No student used their phone for more than 60 hours. Work out the total number of students. So we know this bar is 28, we know this bar is 24. So now we're going to work out the area of these two sections of the histogram, and then we can add them all together. So from here to here is 10, and then up to there. So this is 3. So this must be 3.6. So 3.6 times 10 is 36. And then across here is 20, and then up to 1.6. So 20 times 1.6 is 32. So that's how many people the bars represent. So let's add those together. So 32 plus 36 plus 28 plus 24. 120 people in total. Question 17a. Show that the equation x to the power of 4 subtract x squared subtract 5 equals 0 can be written in this form. So this is an iteration question, and to write it in this form we're simply rearranging this equation here. But we need to rearrange it in a specific order to make it look like this. So let's have a look at the differences. So it's ending up with a 4th root. Now the only way we're going to get a 4th root is if we're doing the inverse of the 4th power. Well, the 4th power is here on x to the power of 4. So what must happen is these terms here move across first, and then the last step is to do the 4th root because everything's inside that. So we have x to the power of 4 subtract x squared minus 5 equals 0. So the first thing I'm going to do is add 5 to both sides. Then I'm going to add the x squared. Remember, you're doing inverse operations when you rearrange. And then the last step would be to do the 4th root of everything that's on the right hand side. Part B. Starting with x0 equals 1.5, use the iteration formula, which is here. It's this formula, but they've used iteration notation 3 times to find an estimate for a solution of this equation. So what this iteration formula tells us is we use the previous term to find the next term. So the previous term is n, the next term is n plus 1. So if I've got x0 equals 1.5, that's the previous term, and I can use that to find x1. So what I'm going to do is the 4th root of the previous term squared, add 5. So let's do that on our calculator. So the 4th root of the previous term squared, add 5. So that's 1.640909017. Now to find the next one, it wants me to do it 3 times. So I'm going to have to do it another 2 times. But what I'm simply going to do, rather than type it all out again, I'm going to go back on my calculator. I'm going to enter in the answer button here where I would put the previous term. So there's my answer button. So now it'll use the answer that I had stored previously. So that's 1.665398002. So then to get the next one, I simply press equals because the answer button's in there. So that's 1.6697630088. So it wants us to use that iteration formula 3 times, 1, 2, 3, to estimate a solution. So what we're going to look at now is these answers. So we've got 1.64, 1.66, 1.66. Now I'm going to look at these last two in particular because they are the same after the decimal point until we get to that third decimal place. But what you'll notice about that third decimal place is they're 5 or above in both solutions. So what I can say is an estimate for the solution would be 1.67 to 2 decimal places because each of these two rounds to 1.67. So I'm going to write 1.67 on my answer line there. Question 18. So we have 2a to 5c equals 6 to 25, 4b to 7c equals 20 to 21. And it wants us to show that a plus b to b plus c equals 17 to 20. So I'm going to take each ratio separately and simplify it a little bit more. Because here I have multiples of the letters, whereas here I only want a single letter. I don't want it in terms of multiples. So if we look at this first ratio, so 2a to 5c is 6 to 25. Well, if 2a equals 6, then 1a must equal 6 divided by 2, which is 3. And if 5c is equal to 25, then c must be equal to 25 divided by 5, which is 5. I'm going to do the same with the other one. So I've got 4b to 7c, which is 20 to 21. So I'm going to make that in terms of b and c rather than multiples of them. So 20 divided by 4 is 5, and then 21 divided by 7 is 3. So now I'm dealing with these single letters. I'm going to figure out this ratio here. To do that, what we notice is I've got c in both of these. So I'm going to rewrite this as a to c to b. So in this first ratio it's 3 to 5, and in this ratio c to b is 3 to 5. I want this middle to be the same. I want it to be equivalent so I can combine these ratios. So I'm going to multiply this one by 3 and this one by 5. So a multiplied by 3 is 9, 5 multiplied by 3 is 15. 3 multiplied by 5 is 15, and 5 multiplied by 5 is 25. So now I can write the ratio as a to b to c. So a is 9, b is 25, and c is 15. So now we can use these values to show this ratio at the top here. So we're doing a add b to b add c, and we're trying to show that it equals to 17 to 20. So a add b, so 9 add 25, b add c, 25 add 15. 9 add 25, that's 34 to 40. And then if we divide this side by 2, that gives us 17 to 20. And we've shown that equivalency. Question 19. ABC is a right angle triangle. So we've got a right angle triangle. We know the side AB. So AB is 9.3 centimetres correct to the nearest millimetre. AC is 12.6 centimetres correct to the nearest millimetre. Calculate the lower bound for the size of the angle marked X. You must show all your working out. So because we're looking for the lower bound, we're going to need the upper and lower bound of these lengths, because this is the information we're going to use to find that angle. So if we do the upper bound of AB, so the nearest millimetre is the nearest 0.1 centimetres. Half of that is 0.05. So for the upper bound, we do 9.3 plus 0.05. Oops. $9.35, and then for the lower bound of AB, we subtract 0.05. .25. So we're going to do the same for the length AC. So the upper bound of AC is going to be 12.6. Now again, it's the nearest millimetre. So 12.6 plus 0.05, which is 12.65. And then the lower bound of AC is 12.6 subtract 0.05, which is 12.55. So next thing we need to do is figure out which of these values we're going to use. So we want the lower bound of the angle marked X. So to find the angle, we'd use trigonometry. So we have the opposite and the hypotenuse. So sin X is equal to the opposite over the hypotenuse. So sin of our angle is equal to the opposite divided by the hypotenuse. Now we want sin to the -1 to find X of the opposite over the hypotenuse. So we're doing a division here. If we want the lower bound, we need to divide the smallest possible number by the biggest possible number, which will then give us our smallest possible answer. So when we substitute these in, we want the smallest possible value for the opposite, which is AB. So we're going to use the lower bound of AB, and we're going to divide it by the upper bound of AC, which is H, because the bigger the number you divide by, the smaller the answer you're going to get. So we have shift and sin, and then it's 9.25 divided by 12.65, close the bracket. So it's 46.989,21356. It doesn't tell us what to round it to. Everything else is to 1 decimal place. So we could write it to 1 decimal place, or we could just leave it like this. So 46.989, and we'll stop it there. Question 20. ORT is a triangle. ORT. OT equals A. So OT equals A. R to T. RT equals B. That's labelled on the diagram for us. M is the point on OR, so OR and M, such that OM to MR is 2 to 3. So OM to MR, 2 to 3. So there's 5 parts in total. 2 plus 3 equals 5. So O to M is 2/5 of that length, and M to R is 3/5 of that length. So it's worth noting that. Express MT in terms of AB. Give your answer in its simplest form. So we want to give a vector for the journey from M to T. To do that, we need to find out that distance here, MR. So we're going to start with O to R, because that's one that we can easily do. So going from O to R, I'm going to go along lengths that I know information about. So O to T, add T to R. So O to T is A, T to R is B, but we're going in the opposite direction to this arrow here, so it would be minus B. So O to R is A subtract B. Now I know if I want to go from M to T, what I'm going to do is go M to R and then R to T. That's the route I'm going to take. So M to R is 3/5 of OR, of this length here. So M to R is 3/5 of A subtract B, and then we would add RT. So from R to T, going in the same direction as this arrow, so we would add B. So now I'm going to simplify this a little bit more. So MT equals, so this is 3A subtract 3B all over 5. All I've done is deal with that bracket. So now I'm going to write these separately. So that's 3A over 5 subtract 3B over 5, add B. So now I can collect like terms. So I can collect my B terms together. So I've got minus 3/5 b plus a whole b. So let's see. So if I've got minus 3/5 and then I'm adding a whole one, that leaves me with positive 2/5. So I have 3a over 5 plus 2b over 5. And that's my MT. You could also write it as 3/5 A plus 2/5 B. It's the same thing. And that's what I'm going to write nice and clearly on my answer line. Question 21. Here is the graph of y equals f of x. This is y equals f of x. Part A. On the grid below, draw the graph of y equals f of x, subtract 4. So this subtract 4 on the end is outside of the bracket, so it impacts the y coordinates. So because it impacts the y coordinates, it means that this graph is going to shift down 4 places. So this point here is at minus 3, 0. So it's going to be at minus 3, but it's going to go down to minus 4. It's going to go from 0 down 4 places. This point here is at minus 2, 1. So minus 2, 1, but then it's going to go down 4 places. 1, 2, 3, 4. And now you can see where the rest of the graph's going to form. But if you weren't entirely convinced, you could plot each of those points separately, moving them down 4 places before you then draw your graph. Okay, next one. Part B, on the grid below, draw the graph of y equals f of negative x. So this negative x is inside the brackets, but what this means is, with a negative x inside the brackets, we're going to reflect on the vertical axis. The vertical axis is this one, so we're going to reflect this graph over the y-axis. So this point here is 1, 2, 3 away. So we're going to go 1, 2, 3 away on this side. So here, and this point here is 1, 2 away. So we're going to go 1, 2 away on the other side. And then 1 away. And then at 0. So that's an invariant point because it's actually going to stay where it is. And then draw the graph. Question 22. There are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. Rita takes at random 1 pen from the box. She records the colour of the pen and then replaces it. The replaces it is important in the box. She does this n times where n is greater than or equal to 2. Write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. Okay, so if we're dealing with blue pens and red pens, let's see if we can figure out the probability of a blue and the probability of a red pen. So blue pens is 4 times the number of red pens. So if red pens was 1, blue pens would be 4 because 1 times 4 is 4. So we have actually a total of 5 pens here if red was 1. So let's go with that for now. So the probability of picking a blue pen would be 4 out of 5. And the probability of picking a red pen would be 1 out of 5. So we have some probabilities here. Now what we would do here then is we would multiply the probabilities together where appropriate with a tree diagram. However, we're writing an expression in terms of n because we don't actually know how many times she does this. We just know that it's going to be greater than 2. So the probability that Rita gets a blue pen at least once and a red pen at least once is the same as 1 take away the probability that she picks all red or she picks all blue. Because any other options will be a mixture of picking red and blue pens. Okay, so the probability of picking red is 1 out of 5. And we would multiply that however many times we did this experiment, which is n. So I'm just going to pop it to the power of n, because it'd be 1/5 multiplied by 1/5 multiplied by 1/5, however many times she picked pens. Okay, we don't know how many there are in total. And then I would do the same for blue. So it'd be 4/5 to the power of n. So 1 subtract this probability, subtract this probability. So the total probability of all getting all red or all blue, depending on how many times she picks these pens, would be our expression. So 1 subtract 1/5 to the power of n and 4/5 to the power of n. Question 23. Here are 3 similar triangles. So similar triangles is important. We've got ABG, ACF and ADE. ABCD and AGFE are straight lines. That's the sides of the larger triangle. AB to BC to CD is equal to 1 to 2 to 3. So that the area of ABG to the area of BCFG to the area of CDEF is equal to 1 to 8 to 27. So we have a proportional relationship here with the ratio in terms of these lengths here. And then we have a proportional relationship in terms of the areas of these 3 parts of this shape. Now you'll notice ABG is the triangle, but BCFG is this smaller section here, trapezium, and CDEF is this trapezium here. So the first thing I'm going to do is I'm going to make some kind of relationship between the lengths of these sides. So I've got A to B, B to C and C to D. So A to B is 1, B to C is 2 and C to D is 3. So A to B is 1, but A to C is 1 plus 2, and then A to D is 1 plus 2 plus 3. So I've got A to B is a side of this triangle, A to C is a side of this triangle, and A to D is a side of this triangle. So I've got that proportional relationship between the sides. So that's 1 to 3 to 6. So this is lengths. We're working with area, so we're going to convert these to areas. So area of ABG is going to be this squared. Area of ACF is going to be this squared. And then area of ADE is going to be 6 squared. So this is the areas. So we have 1 to 9 to 36. So we want the area of ABG, which we know here is 1, to the area of BCFG. Now we have the area of this whole triangle ACF. BCFG, we'll find this if we take that smaller triangle away. So BCFG is ACF subtract ABG. So it's ACF triangle subtract this triangle here. And then the next part of the ratio we want is CDEF. Well, CDEF is this larger triangle subtract ACF. So we're going to do ADE subtract ACF. So ABG, we know the area is 1. ACF is 9. Subtract ABG, which is 1. ADE is 36. Subtract ACF, which is 9. So we have 1. 9 take away 1 is 8. 36 take away 9 is 27. So we've shown that the areas of these parts of the shape are in this ratio. Question 24. The diagram shows 8 identical regular octagons, 1, 2, 3, 4, 5, 6, 7, 8, joined to enclose a shaded shape. Each octagon has side lengths A, so this side is A, this side is A, and so on. Find in terms of A an expression for the area of the shaded shape. Give your answer in this form where P is an integer. Integer means a whole number. You must show all you're working out. So if I want the area of this shaded shape, the first thing I'm going to do is see if I can split it into shapes that I can deal with more easily. So if I was to draw a line here line down here, across here, and across here, you can see that I have a square in the middle, and then I have 1, 2, 3, 4 triangles around the outside. So now I'm working out the area of a square and then the area of 4 triangles. So to work out the area of the square, I need to know, so if this is A and this is A, I need to know this length, because then it would be A plus this plus A. So if I want to know this length, I'm going to find out this angle here. It's going to make my life easier. And this angle here is formed by the exterior angles of these 2 octagons. So the first thing I'm going to do is I'm going to do 360 divided by 8. That tells me the size of the exterior angle of one of the octagons. And this angle here is formed by 2 of those exterior angles. So this then tells me that this angle here is 90 degrees. Now if I take this triangle and draw it here, we have A, and 90 degrees. I need to know this length here so I can find the length of the square to find the area of the square. I know with a right angle triangle I could use Pythagoras. So to use Pythagoras to find this length, I would do A squared plus A squared, and then I would square root it. So this is the square root of 2A squared. Now I can't square root 2 and get an integer answer, so I'm going to write that as root 2, but I can square root A squared and get an integer answer. That would leave me with A. So this length here is root 2A. So I know that the side length of the square is A plus root 2A plus A. So that's 2A plus root 2A. So if that's the side length of the square, I can now find the area of the square. So the area would be this length multiplied by itself, because all the sides of a square are the same. So let's expand these brackets. So that would give me 4A squared plus 2 root 2A squared plus 2 root 2A squared plus 2A squared. So let's simplify that. 4A squared plus 2A squared is 6A squared plus 2 root 2A squared plus 2 root 2A squared is plus 4 root 2A squared. So that's my area of the square. Now I need to find the area of these triangles so I can add those to this area to get the total area of the shaded shape. So area of a triangle. What we could do here is, so area, I'm going to use the trig formula, so it's half times the two sides, so half times A times that enclosed angle, but it's sin of the enclosed angle. So it's a half times A squared times sin 90 is 1. So the area of one triangle is a half times A squared, or A squared over 2. We have 4 of those triangles, so 4 times A squared over 2 is 4A squared over 2, which simplifies to 2A squared. So I'm now going to add these 2 areas together for the total area of this shaded shape. So 2A squared plus 6A squared plus 4 root 2A squared. So that gives me 8A squared plus 4 root 2A squared. Now they want it in this form where P is an integer that I've taken out as a factor. A squared is also taken out as a factor. So if I take A squared out of that bracket there, that's going to leave me with 8 plus 4 root 2 that needs to be factorised. So 8 and 4 have a common factor of 4. So if I pull out 4, 8 divided by 4 is 2. 4 root 2 divided by 4 is root 2. So if we look here, we have an integer, P, 2 plus root 2 inside the bracket and then a squared on the outside. So the answer line to this one is on the other page. They gave us some extra working out space if we needed it. So I'm going to take that expression and write it on my answer line.